Today's lesson is pretty short because we did a lot of the heavy lifting for this lesson at the beginning when we talked about limits from a graph, and we looked at the left and right side of the graph and if our function approached the same value. Today we're going to talk about one-sided limits, where a one-sided limit, we're just focusing on either the left side or the right side. And the way you notice or know that you're looking at the left or right side is you see right here, it says the limit as x approaches c with a little plus in the place of an exponent. So that means it's coming from the right side. Whereas if I'm coming from the left side, you see a negative sign up in that exponent. So when we looked at some of these earlier, said, wait a minute, the limit as x approaches 0 of this function doesn't exist because from the left we're approaching -1, and from the right we're approaching +1. So because they weren't approaching the same value, the limit doesn't exist. But if we only cared about the left side, well, the limit from the left side does exist. It would be -1. The limit from the right side does exist. It would be +1. So the limit not existing overall doesn't mean that the limit from the left or the right doesn't exist either. So let's go back down here and look at these examples. So it says the limit as x approaches -2, and that little plus sign means from the right. All right, so we look at that. Here is -2, x equals -2, and we're going to follow the graph from the right side. It doesn't matter where on the right we start. We're just following the graph this way, and then as soon as we get to -2, the y value that we are getting close to is 0. So the limit from the right is equal to 0. Now from the left, there is no limit because there's no function over here on the left side. So we would say that the limit from the left doesn't exist, but the limit from the right does. It's 0. And because one-sided limits don't equal the same thing, if I were to ask you, the limit as x approaches -2 of the square root of 4 minus x squared, that does not exist because you can't approach that from the left side. You can only approach that from the right side. Similarly, if you've looked at x equals +2, we can only approach that from the left side. We can't approach it from the right side because there's nothing there. So one-sided limits might be a little bit easier because you're only focusing in on one side. All right, now example 2, we want to know the limit as x approaches 0 from the left side of this function. This is called the greatest integer function, or sometimes called the step function because you look at the graph and it looks like stair steps. So as x approaches 0 from the left side, okay, we're following the graph, then it jumps up. Oh, now we're at x equals 0. Even though it is an open circle right there, my y values from the left are getting closer and closer to -1. It doesn't equal -1, but the y value gets closer and closer to that as our x values approach 0 from the left, so -1. Now from the right, okay, going from the right, and down here, we are defined at x equals 0, and the y value is 0. But again, we're talking about the limit. As our x value gets closer to 0 from the right side, the y value is 0. So then that equals 0. So this gives us more practice with reading graphs from left to right, but we again got to be careful that we are looking at what the what y value the function approaches, not necessarily what it is equal to. What function do we get closer and closer to? So like I said, it was going to be a short lesson today. That's it. Except we did a lot of heavy lifting earlier. So just when you're looking at these, just pay attention to what side you are coming from, or maybe you're not coming from any side at all. Maybe you have to go from both sides. So please just make sure that you're paying attention to these like little exponent things there. So thanks for watching. Make sure to like the video and subscribe.